After you multiply polynomials for a while, you run across some special situations. These special situations, well, they're special. Let's take a look at one of these that you might run across sometime. Something like the quantity of x plus 3 squared. Well, you're used to using FOIL, or multiplying binomials by the distributive property, but we don't seem to have two binomials next to each other. But what we do have is a square. The square is simply this number multiplied by itself. This number happens to be a binomial. So we can write it as x plus 3 times x plus 3. And then, using our FOIL pattern, multiplying the first terms, the outer terms, the inner terms, and the last terms, we can then see what happens. Let's do the first terms. X times x is x squared. The outer terms, x times 3 is 3x. The inner terms give us 3x also. And 3 times 3 is 9. Combine the two middle terms, x squared plus 6x plus 9. Pretty cool. Let's try another one. How about 2a minus 3 squared? Well, we can do the same thing we've been doing. Write this as two binomials next to each other, so we can then apply FOIL. 2a times 2a is 4a squared. The outer terms, 2a times negative 3 is negative 6a. The inner terms, negative 3 times 2a is negative 6a also. Negative 3 times negative 3, be careful, you multiply the negative times the negative, giving us a positive 9. Add the two terms in the middle, 4a squared minus 12a plus 9. Pretty cool. How about one more? Let's try another example. Let's try 3m plus 5n quantity squared. Same process. We write these out as two binomials multiplied together. Use our FOIL pattern to see what we get. 3m times 3m, 9m squared. 3m times 5n. 3 times 5 is 15. M times n is mn. Do the same thing with the inner terms. 5n times 3m, it's again 15. And we'll write this alphabetically. mn. And the last term, 5n times 5n, is 25n squared. Combine the two like terms in the middle, giving us 9m squared plus 30mn plus 25n squared. Very cool. All right, let's look at another situation here. Let's try another situation. Let's try x plus 5 times x minus 5. We'll use the FOIL pattern again. First terms, x and x squared. Outer terms, x times negative 5, make sure the sign goes with the term, negative 5x. Inner terms, 5 times x plus 5x. The last terms, positive 5 times negative 5. Positive times a negative is a negative, so we have negative 25. Wow, our two middle terms, negative 5x and positive 5x, those cancel out, leaving us with x squared minus 25. Ooh, interesting. Let's try another one. Let's do 2a minus 3 times 2a plus 3. FOIL it. 2a times 2a, 4a squared. Outer terms, 2a times 3, 6a. Inner terms, negative 3 times 2a, negative 6a. And the last terms, negative 3 times positive 3 is negative 9. Once again, we have a situation here where our two middle terms cancel out, 6a minus 6a, leaving us with 4a squared minus 9. So we've seen a couple situations now we've seen a situation where we have a binomial being squared. We've also seen it where we have a binomial squared with a negative in the middle. And we've also seen this situation where we've got the sum of two numbers times the difference of those two numbers. I wonder if there's an easier way to do this. I wonder if there's a quicker, easier way to do this. If there's some way that is simpler and there's faster, a quicker, to do easier way like to do this. I have an idea. Let's just try this without numbers. Let's say we've got a plus b and we square it. Well, a plus b times a plus b is, first, a squared. Outer, a times b, is ab. Inner, b times a, is also a times b. Last term, b times b, is b squared. If we put these together, we get a squared plus 2ab plus b squared. Wow! All right, let's do the same thing, but with a minus b squared. A minus b times a minus b. Once again, we square the first term, or first term times first term is a times a, which is a squared. The outer terms, a times negative b, negative ab. The inner terms, negative b times a, is negative ba. We can just flip those around and write as negative ab. Negative b times negative b is positive b squared. I have two like terms in the middle, negative ab and negative ab. Combine those, a squared minus 2ab plus b squared. And the last one, a plus b times a minus b. This is an interesting pattern. A times a is a squared. The outer terms, a times negative b, is negative ab. The inner terms, b times a, is a positive ab. The last terms, b times negative b squared, because a negative times a positive is a negative. These middle terms cancel out, leaving us with a squared minus b squared. These are some special patterns that we have discovered. So if we look at this pattern, we see that a squared, that's the square of the first term. B squared, that's the square of the last term. In the middle, this 2, that's double the product of the two terms. If we double the product of the first term and the last term, double the product of the two terms, we get our middle term in this trinomial. It works the same with the a minus b squared. Square the first term, that's a squared. Double the product of the two terms. A times negative b is negative ab. Double it, minus 2ab. Square the last term. Negative b squared is b squared. That's a really cool pattern. I bet this is going to save us some time. What about this one? A plus b times a minus b. I have the sum of two terms times the difference of those same two terms. So I have the square of the first term and subtracting the square of the last term. This is called the difference of two squares. Difference of two squares. I wonder if we can apply this to problems similar to what we were starting with. Let's see, x plus 7 quantity squared. Square the first term, double the product of the two terms, square the last term. Square the first term, x squared. Double the product of the two terms. The product of x and 7 is 7x. Double it, plus 14x. Square the last term. 7 squared, that's 49. Oh, this is super cool. This is so much faster. What if I have 2n minus 5? Square that. Square the first term. 2n squared, I've got to square that whole first term, which means squaring the 2 and the n. 2n squared, 4n squared. Let's multiply these two terms. 2n times negative 5, negative 10n. Double it, negative 20n. Square the last term. Negative 5 squared plus 25. Oh, this is super cool. This is so much faster and easier. I wonder if it works if there are two variables. Like if we have 3a minus 4b and square that whole thing. All right, first term, let's square it. 3a squared becomes 9a squared. 3a squared is 9a squared. All right, let's multiply these things. 3 times negative 4 is negative 12ab. So this is negative 12ab when I multiply 3a times negative 4b. Negative 12ab. Double it. Negative 12 times 2 is negative 24. Negative 24ab. Square the last term. Negative 4b. Square all of that. Negative 4 squared is positive 16, and square the b squared. Oh, I wonder if this works with that difference of two squares. Well, x plus 9 times x minus 9. Square the first term minus the square of the last term. That's it. It's that simple. Oh, what if there are multiple variables? 5n minus 3x. 5n plus 3x. If these two binomials look the same, with the only difference being one has a minus and one has a plus, it's the exact same pattern. Square the first term, 5n. Square that whole thing, 25n squared. Square the last term, 3x. That squares to 9x squared, so minus 9x squared. That's it. These are the patterns. We have a plus b squared, square the first term, plus twice the product of the two terms, plus the square of the last term. A minus b squared, almost the identical situation. It's just we have a minus 2ab in the middle. And if I have a sum of two monomials times the difference of the two monomials, that's just square the first term minus the square of the last term. A squared minus b squared, and we call this the difference of two squares. These are the special products. Special products can easily be multiplied with these patterns. Special products.